In this video, we are going to discuss the topics of atmospheric chemistry and air pollution. We are going to cover the impact of human activity on atmospheric chemistry, discuss secondary air pollutants, and look at a specific example of a pollutant, sulfur dioxide, or SO2. So, what is atmospheric chemistry? Atmospheric chemistry studies the chemistry and composition of the Earth's atmosphere, including how human activity, such as greenhouse gas emissions, affects the atmosphere. The atmosphere is composed of a mix of gases: nitrogen, oxygen, argon, carbon dioxide, and a variable amount of water vapor, between 0 and 4% depending on surface conditions. The atmosphere is also home to a variety of natural processes, including the cycling of water, nitrogen, sulfur, and carbon, cloud formation, and air circulation. What is air pollution? Air pollution is a mix of hazardous substances from both human-made and natural sources released into the air. Globally, the most impactful air pollutants include particle matter, PM, carbon monoxide, ozone, nitrogen dioxide, and sulfur dioxide. Most atmospheric air pollutants are produced by human activity, like industry, transportation, and energy generation. Most atmospheric pollutants are also secondary pollutants, which are created through chemical reactions between primary direct pollutants and gases in the atmosphere. Let's dive into an example of an atmospheric air pollutant, sulfur dioxide, or SO2. How is it getting into the atmosphere? A natural process that can result in a release of sulfur dioxide into the atmosphere is volcanic eruptions. However, most sulfur in the atmosphere is a result of human activity, specifically combustion of fuels containing sulfur, like coal. So, what happens when sulfur dioxide is released into the atmosphere? Sulfur reacts with water vapor in order to create sulfuric acid, H2SO4. Sulfuric acid is a primary component in what we know as acid rain. Natural rain pH ranges from 5 to 7, and anything below that is considered acidic. This is a figure of mean pH precipitation during the 1970s in the US, the height of acid rain. Acid rain harms aquatic ecosystems by corroding fish and dissolving heavy metals out of sediment. In terrestrial ecosystems, acid rain depletes soil nutrients. In this video, we have defined atmospheric chemistry, covered air pollution, and took a look at an example of an air pollutant, sulfur dioxide, which reacts in the atmosphere to become sulfuric acid, a primary component of acid rain. On this slide, I have listed my references.